Hi everyone and welcome to the internet. So what we're going to be doing in this term's work in our triple chemistry is looking at rates of reaction. Now this is one of those topics that is pretty much a guarantee to come up and also highly likely to be a 6-mark question if past papers are anything to go by. It lends itself really well to that. So this is a topic that I think is a really nice one and should be one you should score well on. So to start us off today, what I want you to have a go at doing then is in your books, I'd like you to write down how you could measure the rate of reaction between a magnesium ribbon and hydrochloric acid. So to do this, I want you to write me a list of the bits of equipment that you are going to use and the method. You can use a diagram if you want to, but the diagram isn't compulsory. What I'm looking for is a list of equipment and a method of how to do this. So I'm going to give you about 5 minutes to get this done in your books. Now, there are actually a few different ways that you could have come up with an experiment to actually find the rate. One of the easiest ones is the one I've outlined here for us. So what we're going to use in terms of our equipment, and this will be the same no matter what experiment you've got, magnesium ribbon and hydrochloric acid. Those two are compulsory no matter what method you've used. Now, in the experiment I'm going to outline, we're also going to use a test tube, a measuring cylinder, and a stopwatch. In terms of how we can do this, then first of all we use our measuring cylinder to ensure we've got a fixed volume of acids. In this case we're going to measure 10 centimeters cubed of our hydrochloric acid. Then we pour that acid into our test tube from the measuring cylinder. We can then add our piece of magnesium ribbon and we start the stopwatch. Then once that magnesium ribbon is no longer visible, you stop the stopwatch and that gives us the time for the reaction. And we could obviously do this with different concentrations of acid, with different numbers of bits of magnesium, with different sized bits of magnesium. There's lots of different variables we could change here. Now, some of you may have described ways we could do it by collecting the gas, and that's absolutely fine, and we'll be looking at those a bit later on in this lesson. Next thing I'd like you to have a go at doing then is writing me a definition. So write me a definition for this term, reaction rate. So jot that down in your books for me. I'll give you 1 minute to get that done. So when we're talking about the reaction rate, what we're referring to is the measure of how quickly the reactants are used or the products are formed. So make sure you've got that definition written down in your books if you haven't already got that. I'll leave it up there for about another 30 seconds for you. So if the reaction rate is a measure of how quickly our reactants are used up or how quickly our products are being made, what I want you to do is just suggest what we could actually do, so some kind of a calculation that we could carry out to actually work out this rate of reaction. So jot down your ideas in your book now. I'll just give you 30 seconds to do this. How could we calculate the rate of reaction? What we need to do to calculate the rate of reaction then is the amount divided by the time, because it doesn't really matter if we're looking at the amount of our product formed or the amount of reactant being used up. We've got an amount there. Now, what you're going to find is in the vast majority of the experiments that you'll be asked about on the exam, it's going to be the amount of product made, and this product will almost always be a gas. So it will be the amount of our product made divided by the time it took to make that. So amount divided by time, make sure you learn that, because they're not always going to give that to you on the exam paper. So to calculate the rate of reaction, it is the amount divided by the time. One of the other key things they could ask you to do in this particular topic as exam questions is actually applying some of those mathematical skills. Now, as we know, on the exam paper, we are going to be expected to do a certain number of maths-based questions. And one of the ways that you are going to have to demonstrate this is by drawing a graph at some point on some of your papers. It's a guarantee there will be graph drawing at some point across those 6 papers, potentially more than once. Now, if we are drawing our graph to actually calculate the rate of reaction, then we would draw one like the one I've given you here. So we've got our time on the x-axis, and on the y-axis, the vertical axis, we've got the volume of gas. So in this experiment, we're making a gas, and we've recorded it on our graph there. Now, what we can see is that it's not just a straight line. It starts off with an approximate straight line, but then it curves off at the end. Now, that's because when we're carrying out an experiment like this, we're going to reach a point where we will not make any extra product. All the reactants would have been used up, so it will level off. Now, what we can actually do then is use this graph to calculate the rate of reaction. And there are going to be 2 ways that we could do this, or be asked to do this. The first one of these ways is to find the mean rate. Now, this is where you're going to have either the mean rate of the whole experiment or potentially the mean rate between 2 times that they will give you. So in this one, I've asked us to find the mean rate between 0 seconds and 80 seconds. So in order to do this, from your graph that you've probably drawn for about 4 marks in the previous part of the question, then what we actually do is we need to identify those 2 times that we've been given. So 0 is obviously in the bottom left corner, so that's just our 0 point, and then we need to find 80 seconds. Now, from 80 seconds, we're going to use a ruler and a pencil to draw a nice straight line going up to the actual curve that we've got. So you draw a nice line going from 80 up to the curve. Then, from there, you again use your ruler and your pencil to draw a line across to the y-axis, so you can actually read off accurately. Now, yes, of course, you could just do this by eye, but all too often when you're looking at those bits of graph paper, it's so easy just to lose your line of sight just by a square, and then you're off, and that means you're going to get it wrong. So use your ruler and pencil really carefully, take the time to line it up, and then what we can do is read off those values. So in order to actually work out the volume, then what we need to do is have a look at our maximum volume, so the top point there, which is actually 46 centimeters cubed, and then for 0 we had no gas, so 0. So 46 minus 0 is 46 centimeters cubed. That's how much we made across those 80 seconds. Then we need to work out the difference in our time. In this case, from 0 to 80 is just 80 seconds, and then our rate is the amount divided by the time. So 46 divided by 80, put that into your calculator, and we get an answer of 0.575. So what I'd suggest you do is just jot down a couple of points, maybe a sketch of the graph just showing you how to do it in your books, just as a reminder as to how to calculate the mean rate. So I'll leave this up here for about a minute. The second style of question they could ask us is to calculate the rate at a specific time. So they'd say calculate the rate at 100 seconds, for example. Now, in order to do this, we can't just look at 100 seconds, find the volume at that point, and then just divide. That's not going to give you the right answer at all. That's how people throw away the marks on this question. What we need to do is draw a tangent to the curve. Now, this is something you may have done in maths, you may not, so we're going to go through it one step at a time. So I'd suggest that as we go through this one step at a time, you just jot down in your own words how to do this. So we're going to use the same graph that I drew previously, but the first step here is, if we're calculating the actual rate at 100 seconds, then we place our ruler at the 100 second point, so it's touching at 100 seconds there. Then what we need to do is you need to angle that ruler so that on each side of that point you've got approximately the same amount of space between the ruler and the actual ruler, the curve, sorry. So what we can see there is I've lined up the ruler so you've got approximately the same space between the ruler and the curve on each side of 100 seconds. Now don't go too far from that, obviously, because it's a curve, so it will change. But close to that point, make sure it's approximately the same on each side. Once you've got your ruler in the right place, then using a sharp pencil, please use a sharp pencil for this because you only get one bit of graph paper printed in the exam paper, so pen, bad news, and also make sure it's sharp because otherwise it's going to be terrible to use. Then we draw our line where the ruler was. So you've got the line from where the ruler was at this point. Then what we're going to do is pretty much make our own triangle. Now, what I suggest you do here is select the points for your triangle that are easy to read. You've got complete flexibility here because obviously your line, your tangent there, can be as long as you want it to be on the bit of graph paper. So pick whole numbers where possible to make your life far easier. So don't do the tiniest little triangle, try and make it a decent size like we've done here. So what you're going to do is you are then going to follow down from that tangent to draw a right angled triangle. Okay, so make sure you got your right angled triangle. Then we go back to the same thing we did when it was the mean rate. We work out the difference between the volumes and those 2 points and the time for those 2 points. So for our triangle, what we're going to do is have a look and we can see the difference in the volumes. It's 63 at its highest point and it comes down to 40. So 63 minus 40 gives us 23. And then for our time, it's going from 160 seconds as our highest down to 42 seconds. So 160 minus 42 gives us 118 seconds. So we work out the difference in our volume and the difference in our time from our triangle. now we've got those differences, we can use our rate calculation. So remember, rate is the amount divided by the time. So in this case, 23 divided by 118, put that into your calculator, and we get the rate of 0.19 to 2 decimal places. There were many, we're only going to go to 2 in this case. So that's how we can then calculate the rate at one specific time. Draw the tangent, calculate the difference in the amount and the time, and then divide them. So it's not too tricky, just remember to draw that tangent first of all. Okay, in your books what I'd like you to do is write down how we can measure the volume of gas made in an experiment. If you can come up with more than one way, fantastic. Write down as many ways as you can. I'm just going to give you a minute to get that done. So aside from the good old counting bubbles method, which we talked about at the end of last term's lessons, we've got these two methods that we also touched upon. So the first one is the upturned measuring cylinder. So we've got a measuring cylinder filled with water, which we've turned upside down in a tub of water, and we then have our delivery tube placed underneath. So all the gas that's made bubbles through the delivery tube into our upturned measuring cylinder, and we can then just read the volume off the side because the water is displaced. The second option is we connect the gas syringe in, and you can see that in the diagram on the right. So I'd suggest you get those two methods for measuring the amount of gas produced in a reaction written into your books. I would suggest doing a little sketch of those diagrams as well. But obviously, if you don't have enough time to get them done right now, you can always pause the video. I'll leave this up here for about 1 more minute, but if you need more time, I'll give you a warning so you can hit pause. If you still need a little bit more time with this, then hit pause now. Okay, next thing is actually looking at the results we've got and actually doing something with them. So what I've given you here is a table of results. What I want you to do is, first of all, look at that results table and suggest how we can improve it. So any points on how that table could be improved, write those in your book. And secondly, identify which of those results is the anomalous result. So also referred to as the anomaly, the outlier. Which one of those results is the anomalous result? I'm just going to give you about 1.5 minutes to get that done. So what I've got on the screen for you here then is the improved results table. So hopefully the things that you picked up that were missing, first of all, any units at all. We didn't have any units for temperature or for the volumes. So you should have had degrees Celsius for temperature and centimeters cubed for each of the volumes. The next thing that I would say we should include in our results table is the mean volume. We did that experiment 3 times. We're clearly not going to be plotting all 3 results on a single graph or either drawing 3 graphs. That's crazy. What we do is we calculate the mean. So what I've got there for you is the results table as it should be. So what I want you to do then is have a little look to see, did you get those right? If you did, give yourself a tick for the different units and 1 for the mean. Now, the last point I asked you to do was to work out the anomalous result from that table. Hopefully, we picked out the one I've got in red for you, volume 2 for 45 degrees Celsius. Because if we look at the other 2, we've got 30 and 32, and then the 50. So what we're looking for with our anomaly is the one that doesn't fit with the others. It's way out. So what we can see there is we'd be expecting something around 30 again, but instead it's 50. It's an outlier, an anomaly. So that one is a problem. Now, one of the things that you will be asked to do is to calculate means, and hopefully we remember that to calculate the mean, we add up the results and then we divide by however many there were. So what I want you to do very quickly for me is work out the means for each of those 4 temperatures. Now, remember, if we've got an outlier or an anomaly, we don't include that when we calculate the mean. So work those 4 out for me, write the answers in your books. I'll just give you another minute to do that. Okay, let's double check that we got all those means correctly calculated. So for 0, we should have had 2.6, then 5.6 for 15, 15 for 30 degrees Celsius, and finally 31 for our 45 degrees Celsius. So add them up, obviously give yourself a score out of 4 for that for me in your books. Last thing for today then is our plenary questions. So again, those of you with target grades up to a grade 5, then it's the 2 on the left. Those of you with the target grade over a grade 5, it's the 2 on the right. So what I'm going to do is I'll leave these up for about 30 seconds, but if you need more time, obviously just hit pause. I'm expecting you still need more time to get these finished properly, so hit pause now and finish off those questions. Don't forget you can find the answers to the plenary along with other questions that you can get on with over on my website. So just go to the Internet School tab and then find the resources for this week. For those of you that are actually in my real world classes, if you like, then you will have noticed, hopefully anyway, in your school email that you have got an email from me with instructions on how to submit an assessment based around the chemistry work we've already done last term. So please go onto your school email addresses, look at the instructions. It's a document that you'll find in Shobi. It's completely free. I want you to download it, write your answers in there, just in Word document, and then just drop it back into Shobi for me. That means that I can then mark that and give you a bit of feedback on the work we did last term. So make sure, check school emails, get on to do that for me. Other than that, I look forward to seeing you next time.